So hi guys, today we're going to be doing some proof by induction. So I've had to do a few attempts at this because I've made some errors, but I think I finally got it now. So let's try it. So first we always start off with the base case. So you let n equals to 1. So n's going to go to 1, so you would just have r squared, so that's going to be 1 squared because r is equal to 1. Is going to equal to, well, this is the left hand side first and that's the right hand side, first label that, and that's going to equal to n over 6, which is 1 over 6, n plus 1, that's going to be 2, that's going to be 3, so that's 6, 6 over 6 is 1, so that equals to 1 as well, so right hand side equals to the left hand side, that's true. Now we want to do the assumption. So that's assuming n equals k is true for the statement. So what we would do is now sub in k as n. So you have k, r equals 1, r squared is equal to k over 6, k plus 1, 2, k plus 1. Now we want to do the inductive step. Let me just move this up so you guys can see. Now this is going to essentially let n equals k plus 1, and we're trying to show something, so aim to show. So now what we want to do is we kind of want to put k plus 1 instead of n, so we want to put k plus 1, r equals 1, r squared is equal to k plus 1 over 6, k plus 2, 2k plus 3. So how I got 2k plus 3 is I put, so instead of here k, I put 2k plus 1 in brackets plus 1, expand that out, you get 2k plus 3, same with this, so instead of k plus 1 it will be k plus 1 plus 1, which is k plus 2. So yeah, we're on this stage at the moment, so let's turn over. So how I wrote this, so k plus 1 to 1, so r being 1, r squared can be written in the form of k, sigma notation 1, r squared, plus k plus 1, sigma notation k plus 1, r squared. This is one term, so this will become k plus 1 squared. And this is going to be different terms, so this will be k over 6, k plus 1, 2k plus 1. So now what we want to do is we want to kind of expand it if you want, but this is an easier way. So instead what you could do is you could take k plus 1 as a factor, swap this in, so you have k, 2k plus 1, put that in brackets, plus 6 times the amount of k plus 1, so that's equal. Let's move this up a bit. And now what we want to do is we can expand this out, so k plus 1 over 6, 2k squared, yeah, 2k squared plus k plus 6k plus 1, yep, this looks right, k plus 1 over 6, 2k squared plus 7k plus 1, k plus 1 over 6, 2k, this is just how I factorize. You could do different ways, you could do the quadratic formula and stuff, but this is how I do it. So it'd be times, did I make a mistake? Plus 1. I should be plus 2. So, okay, let's see if we can spot the mistake. So that's k plus 1, 2k squared plus k plus, that should be plus 6, that's it. And there you go. And now back to where we were, so this is going to be 2k plus 4, that's going to be 2k plus 3, divide this by the coefficient, so k plus 1 over 6 k plus 2, 2k plus 3. And we're done. So I've proved that the formula is given in the form n over 6, n plus 1, 2n plus 1, I believe it is. But we're not done, since we need to write the conclusion. So, conclusion is going to be, I have proved the statement is true for n equals 1. Oh, 1, sorry, not k. I have assumed the statement to be true for n equals k, given assumption I showed it is true. Don't know if you can see that, you should be able to, for n equals k plus 1, and therefore by mathematical induction the statement is true for all positive real integers. So that's how you do it. So just some notes I will write down here is base case. That's the first step, where you let n equal 1. Assumption, let n equal k. Inductive, where you do aim to show, which I highly recommend, so you know what you're trying to prove rather than blindly guess what your answer is going to be. Second to last is proof, where you show n equals k plus 1 is true. And the very last step, which you must not forget and must be quite good, is your conclusion, where you state what you have done. So say that you've proved it for n equals 1, you've assumed it's true for n equals k, given the assumption you have said it's true for n equals k plus 1, therefore by mathematical induction, therefore it's true for all positive real integers. So that's it, guys. If you want me to do more videos on this, yeah, I will. It might take me a little while to get to it, but yeah, that's it really. See ya.